Here is an example of how to do the simplex method. We are asked to apply the simplex method to the problem below, and the variables are x, y, s, t, and f. So this first column here would be the x column. This next column would be the y column. The 4, 1, negative 3 would be the y column. S column, t column, and f column there is what we're working with. To start with the simplex method, we start by looking at the bottom row, and we want the column with the largest negative. That would be our y column here. It's got a negative 3 on the bottom. It's the largest negative. Technically, it's the smallest number in the bottom row that's negative. That's also negative. Negative 3 is technically smaller than negative 2, but a lot of times you use that vernacular of largest negative to do that, even though it technically isn't correct. All right, so once we found the column, what I want to do is I want to take the values over here in our far row, the solution row, the row, and divide those out. 48 divided by 4 gives me 12, and 6 divided by 1 is 6. We want to choose the smaller of those two values. So my pivot row would be the second row, 3, 1, 0, 1, 0, 6, and our pivot would be the 1 there. So now what I want to do is do row operations using that 1 to create zeros above and below it to turn the rest of that column into 0. So I'm going to do negative 4 times row 1, times row 2, add it to row 1 and put it into row 1 spot. And the other row operation that I need to do is 3 times row 1 plus row 3 and put it into row 3 spot. So let's do those kind of one at a time. I'm going to leave the second row the same. And then I'm going to multiply everything in that row by 3, or by negative 4, and add it to the first row. So 3 times negative 4 would be negative 12, and I add it to the 13, it gives me 1. Negative 4 times 1 is negative 4, plus 4 gives me 0. Negative 4 times 0 plus 1 stays 1. Negative 4 times 1 plus 0 becomes negative 4. Negative 4 times 0 plus 0 becomes 0. And then negative 4 times 6 is negative 24. Negative 24 plus the 48 gives me a positive 24. All right, and then let's do 3 times row 1 plus row 3. So 3 times 3 is 9. 9 plus negative 2 is 7. 3 times 1 is 3, plus negative 3 gives you 0. 0 plus 0 is 0. 3 times 1 is 3, plus 0 is 3. 3 times 0 is 0, plus 1 is 1. And 3 times 6 is 18, plus the 0 gives us 18 there. And now we've got all positive numbers in the bottom row, so we are at our ideal solution. If you want to, let's take a little bit of time to read off this solution here. This bottom equation, if I convert that back to equation, it says that 7x plus 0y plus 0s plus 3t plus f equals 18. And if I solve for f, I get 18 minus 7x minus 3t, subtracting the 7x and the 3t. 0y and 0s disappear, of course. And what I can see is my goal is to try to make f as large as possible. And if I make x any larger, and I also have that all my variables have to be 0 or greater. So if I make x, if I take it for anything other than 0, it's going to subtract from the 18. It's going to make the 18 smaller. If x is equal to 1, I'm going to have 18 minus 7. And that's going to give me 11. It's going to give me a smaller number. So the biggest I can make f is if I let x equal 0 and t equals 0. Same thing's happening there with t. Because these values are negative over here on this side of the equation, they're going to subtract from the 18 if I try to give them a value other than 0. If I try to make them some positive number, they're going to subtract from f. And my goal is to maximize f. So I know that I'm at the optimal solution. And that corresponds to having positive numbers back in the bottom row over here when we're done. So I know that my maximum is going to be 18 when x and t are 0. Now if I go back and look at the other two equations, each one of these rows is a different equation. It's x plus s minus 4t equals 24. And I've decided based on my objective function that I want x to be 0 and t to be 0. And so if x is 0 and t is 0, that leaves me that s is equal to 24. That s is 24 there. Or kind of an easier way to look at that, this was the x, the y, s, t, and f, is that s column is a really nice column. It's got the 1s and the 0s on it. And so s is going to be, and the 1 lines up with the 24, so I want s to be 24 in there. The y column here is also really nice, and the 1 lines up with the 6, so I want y to equal 6 in there. Or if you want, you can turn that into an equation. You've got 3x plus y plus t equals 6. And I've already decided that x should be 0 and t should be 0. Otherwise, I'll be subtracting from my value there. So x should be 0, t should be 0. And so if x is 0 and t is 0, then y has to be 6. Or you can just look for this nice columns in the matrix, the 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1 columns there. And wherever the 1 lines up with the number on the far right side, those are our values. So I get x equals 0, y equals 6, y equals 6, s equals 24, t equals 0, and f equals 18. And that would be our ideal solution there.